Hello, everyone. My name is Ben Whitehead, and I am presenting my midterm on my Applied Analytics project on the escalation of commitment and player resources in Major League Baseball. In 1976, Barry M. Stahl first mentioned escalation of commitment in his work titled Knee Deep in the Big Muddy, a study of escalating commitment to a chosen course of action. I have focused on using the cross-industry standard process for data mining methodology. It is a widely used methodology for data mining and analytic projects and provides a structured approach to the project's overall life cycle. I will start with business understanding. Major League Baseball is in the sports and entertainment industry and enjoyed over $12 billion in revenue for 2023. The league was formed in 1903 when the American and National Leagues merged. It has grown from the original 16 teams to 30 teams with players from over 20 countries. Before 1965, teams were free to recruit youth however they saw fit. This allowed the more established and successful teams to create an air of dominance due to their bankrolls and massive scouting networks. In 1965, the draft was formed as a safeguard for the league, teams, and players. The draft worked in reverse order of the previous season standings. Though the front office, scouts, and managers discussed who they wanted for the team, ultimately, the general managers made the final decision. Our objective is to study the escalation of commitment as evidenced by player resource usage in Major League Baseball. We believe that players drafted at the end of higher rounds are used more than players drafted at the beginning of the subsequent round when the quality of players should be relatively equal. To understand player resource usage bias, we will measure various in-game statistics and the effects of draft position in management change. We will publish a research paper with our findings. Our null hypothesis is that there is no difference between the populations, and our alternative hypotheses are 1. Managers responsible for selecting players in the draft will escalate their commitment and offer more chances to a player chosen in the last positions of the first round compared to a player selected in the first positions of the second draft round. 2. This difference in escalation of commitment will disappear when there is an organizational leadership change. 3. Firms that suffer from an escalation of commitment underperform or exhibit a competitive disadvantage. For my resources, I have the expertise, support, and guidance of Dr. Ungarano, Dr. Rudy, and Dr. Sigler. I have access to proprietary raw baseball data in various spreadsheets and databases. I will be using Excel, Stata, Python, and R to collect, sort, clean, and analyze the data. My team requires me to compile, merge, clean, and model test the data. My only constraints are the accuracy of the current data and the availability of additional data beyond what we already have collected. Some of the risks I face are common issues within group dynamics, running out of time this semester, and if no significant or interesting data is discovered. January and February are for data collection and cleaning. February and March are for initial modeling, regression discontinuity analysis, hypothesis testing, and model evaluations. In April, we will draft our research and begin submission for publication. Data understanding. The data is in a shared Google Drive with two main folders, a raw and a cleaned folder. There are numerous files with significant amounts of observations and fields. They consist of player statistics and player, employee, and team information. The files are either in CSV, Stata, Excel, or numbers format. While becoming familiar with the data, I discovered numerous data entry errors and some missing data. I also uncovered very complicated and uncommented Excel codes. I started with the player data statistics file and the front office project. The main player file is in Excel and is difficult to use on a personal computer. Data preparation. My first task was to create a file with the tenure of general managers for each organization from 1965 through 2020. I completed roughly 65% of the task using the front office project file, and with the research assistant's help, we manually searched and entered the remaining information. The second part of this task involved utilizing a Python script to compare two different data sets and create new variables for whether a management change had occurred, whether that change was an internal hire, and how many years after a player's draft the management change occurred. I then merged my new variables with the dataset in Stata and began some initial testing to see if we were on the right path. My initial testing showed significant differences in the populations depending on whether a management change had occurred or not. I was then asked to create industrial and team turbulence controls to help control for either team or industry effects in the modeling. Here, I use Python script to read in the appropriate data and create the needed variables. Currently, I am still meeting with Dr. Ungarano to continue working on the needed variables that were put forth in an ideas to test document. My next task will be to create a normalized performance statistic for pitchers and batters, and to test whether or not someone was drafted in high school or beyond. Once these variables are created, I will begin my initial phase of modeling to determine which seems to be the most significant variables and models. Then I will begin testing and evaluating these various models and the visualizations that we can get from them. Thank you for watching my presentation, and I look forward to sharing my results with all of you.